So good evening, everyone. Except, of course, if you're in Australia, it's bright and early the following day. My name's Dendra Best. I'm the Executive Director for WasteWater Education. I'm the one that you've been emailing backwards and forwards with and who got your registration information from me. The presentation tonight or tomorrow or whatever time of day it is that you're watching this is on-site domestic wastewater treatment systems. Um, this is about Australia and the Australian perspective. The speaker tonight is Dr. Michael Short from the University of South Australia. Our host for this evening is Ben Keeley, who's with Aris Water. He's also one of our board of directors. And if you're wondering about the background image that you're looking at there, that is the community of Finke, which is pretty much the geographical center of Australia. It's also an Aboriginal community. I'm going to put the link in there to credit the image. As you can see, that's a very remote location, and I'm pretty sure that almost everything there has some kind of decentralized system. Before we get underway tonight, we do have to thank the WET folks. Let me just make this a little bit bigger here. The WET show, and let me put the link in there too into the chat window. The Water and Wastewater Equipment Treatment and Transport Show. It is one of the world's largest annual trade shows for water, wastewater, and environmental services. It also offers a pretty substantial education program, a whole exhibit floor of live demonstrations and equipment, and it's a wonderful opportunity for networking. As you probably realize, the Expo Center in downtown Indianapolis has been closed because of the COVID-19 situation since just after this year's WET show. And as a result of that, it became really obvious that training of any sort was going to be compromised and that people were going to be caught without ability to do sessions such as this. So we have partnered with Douglas Lugo and the WET show folks to bring you these events, and we'd like to have you listen to Douglas doing the introduction.
Hello, my name is Douglas Lugo, the director of the WET Show, and I'd like to welcome you to the session. The WET Show team has put together a series of CEU qualification classes that we hope you will find helpful. These are uncertain times. It's extremely important to be up to date on how the wastewater industry has been affected during COVID-19. The WET Show team has launched the WET Plus initiative as a one-stop shop for resources meant to help our industry stand tall. Please visit our site, The WET Show, that's www.ettshow.com, to access these resources. And remember, we are essential. Thank you and enjoy the session.
So our host for this evening is Ben Keeley, and I'm going to ask Ben to talk a little bit about Michael and about the series in general. Take it away, Ben.
Thank you, Dendra. Today we've got a presentation from Dr. Michael Short, who's from the University of South Australia and is a member of the Future Industries Institute team. Michael has a background in water systems and looking at water quality, wastewater treatment, water recycling, focusing in on environmental microbiology and microbial ecology, and tying that into sustainability and life cycle assessments. And Michael has drawn the short straw as far as getting out and having a look at the Harndorf on-site wastewater, domestic on-site wastewater accreditation scheme based in Harndorf in South Australia. The accreditation scheme is put together by the Australian standards. So for those of you who are standards geeks, it's 1546.3, I think, Michael. And yes, as part of the WET show of webinars, we're been talking about all things water, but I have a passion for on-site and decentralised wastewater systems, and I'm incredibly happy that Michael's presentation so far has been the most popular as far as registrations coming through and people rocking up to attend. So without further ado, I'd like to introduce Dr. Michael Short and get the presentation underway. Thank you, Michael.
Okay,
Yeah,
thank you, Ben.
just one thing before Michael gets started here, just to remind you that if you're watching this event on the original recording, any of the windows that you see on the screen, you can make full screen by just toggling in the top right corner. You'll see a full screen toggle switch. However, if you are watching this on the YouTube recording, you won't be able to do that. So sorry to interrupt, Michael. Take it away.
That's
and why don't you put your presentation on play?
Thank you very much. Okay, hopefully that's working now.
Yep, that's fine.
Yep, okay. So yeah, thanks for that, and good evening, everybody. Hopefully you've got a nice glass of wine at the ready. As Ben said, we'll be covering a bit of an Australian perspective on on-site systems and really focusing in on the standard and the testing of systems against this relatively new standard which has come out in Australia for small on-site systems. So a bit of an overview. Ben's already introduced me briefly, but we'll go over that again. Introducing ARIS as well, a little bit about on-site wastewater systems, and then providing a bit of an overview of the standards or regulatory landscape for small on-site systems internationally, obviously focusing more on the Australian context with which we're most familiar here. Then we'll be giving an overview of ARIS's on-site compliance testing facility up in Adelaide Hills, in a town called Harndorf, so we'll be learning a bit about that, providing a bit of an overview of some of the results coming out of these systems as much as we can, and some of the lessons learned as well, and then finishing up with some discussion points that we can get into afterwards. So who am I? I probably ask myself that question more than I'd like to admit. But for the purposes of this, I'm working at the research institute called the Future Industries Institute at the University of South Australia here in Adelaide. And as Ben said, broad interests ranging from environmental health, environmental protection, sustainability assessment, life cycle assessment, water quality, environmental microbiology. But I guess a lot of those things revolve around a central theme of wastewater treatment. So that's one of my passions. As it is one of Ben's passions as well. So where am I? I'm in Adelaide. I'm not sure, maybe many of you haven't heard of Adelaide or been to Adelaide, but apparently it's the 5th most livable city in the world, which is a little bit curious even for people from Adelaide to see that number. But anyway, apparently it's quite a good little town. These are some of the pictures from around South Australia that you might see. Social distancing is measured in kangaroo lengths, which maybe is a bit different to over there. So, yeah, it's a nice place. University of South Australia, so this is where I work. It's the state's largest university, has 6 campuses, 2 research institutes, some gratuitous ranking statistics there that the university loves to put into these sorts of things. But the UniSA really has a focus on applied research with industry and end users, so that's why we found ourselves collaborating or working with ARIS here on this particular project. So a little bit about ARIS, if you're not familiar with them from some of Ben's previous presentation material. So they have core strengths in water and wastewater systems and in agriculture and environmental systems and solutions as well. In terms of water, the water branch covering everything from potable to recycled and wastewater systems and everything in between. And really they have a specialty for providing sort of fit for purpose, unique solutions with a focus on complex job or unique job that that are sort of in the too hard basket for other companies. So that's an ARIS specialty. So moving on to on-site wastewater systems. I assume most of you are familiar with them. In terms of wastewater treatment and generation globally, obviously centralised, the large centralised sewer with a centralised wastewater treatment plant is sort of the commonplace situation in our metropolitan areas, and obviously there's a large number of these systems around. The predominant process activated sludge obviously has a long history, past 100 years in 2014 I think it was. But in terms of the amount of people sewered globally, the estimates are a bit rubbery. They range from anywhere between 30 and 60%, so can be almost no centralised sewage in some countries, up to almost 100% in other developed nations. So obviously that's a large fraction of people out there that are requiring on-site solutions. In terms of the USA, some of the numbers I've seen there, I believe it's around about 20% of households served by on-site systems, so that's relatively a high proportion. Compared to Australia, it's say less than 10%, just under 10% of the population not connected to centralised sewage. So again, there's lots of people in there requiring on-site treatment systems. In terms of on-site philosophies, there's probably more than two, or sort of a mix of these two extremes. But I guess if you want to put it into two categories, they generally fall into a passive or a natural system approach, or an engineered aerobic system, which we call AWTS here, aerobic wastewater treatment system. In terms of the pros and cons, probably you'll be familiar with some of these, but passive systems quite often cheaper and obviously lower maintenance. They can be designed and they can achieve very high quality effluent on par with the more advanced aerobic systems if they're designed and operated well. In terms of the engineered aerobic systems, some of the advantages there, obviously they can be a smaller footprint, so that can be attractive for constrained sites. And most of them, if not all of them, provides disinfection, which in some cases is a requirement. I know in some Australian states it's a requirement that you have disinfection, so it satisfies that requirement there from an effluent safety perspective for discharge. So again, some of the benefits of passive systems. ARIS are big supporters of passive systems, so and some of we're spending time going over some of the benefits. So there's particularly a good scope to customise the treatment solution to suit site-specific requirements and water quality objectives, which you don't always have in sort of a package aerobic plant, if you like. So it gives you a bit more flexibility there. Lower cost, obviously capex, capital and operating expenditure lower given the passive operation. It can be more robust in terms of operation, so a lot more stable. This set and forget approach actually works, or it can work well in the passive system, as it does for a properly maintained septic tank. So we're discussing a bit more later on, but sometimes the more highly engineered advanced systems can suffer from reliability issues, so we say. So we'll touch on that a bit later on. And potentially lower environmental impacts in terms of low energy, potentially lower emissions than aerobic treatment systems running an activated sludge type process, although if they're poorly managed in both cases, they can potentially have large greenhouse gas emissions. Again, some of the benefits. So this is just a screen grab from a textbook looking at a septic tank plus soil dispersal system. So obviously you can see quite high BAD and solids removals, potentially good nutrient removal in terms of ammonia, nitrification, and also phosphorus removal. Pathogen removal as well. Again, it depends probably on your soil profile a bit, but just showing there again that passive systems really can be designed and operated to achieve very good effluent outcomes. So on the flip side, it's not all roses. Obviously there are pitfalls. with on-site wastewater systems. So in terms of a centralised approach where you have all your wastewater going to one centralised facility with one pipe going out, it's obviously easy to measure and manage effluents going out, but for dispersed on-site systems, having this regulatory oversight is a lot more challenging. So you've got these multiple points of compliance versus a single point for a centralised plant. As I said before, there's often issues with proper performance and maintenance of some on-site systems. So when you're outsourcing the management of these systems and their maintenance to householders, that doesn't always work, depending on how excited your householder is about wastewater, which is not always as excited as we are. And as I mentioned previously, this set and forget approach often doesn't work, and there is evidence actually from a number of surveys that many on-site systems do underperform and have high failure rates. But at the same time, at least in Australia, and I understand it's the same in the US, a lot of the regulators aren't looking, or they're happy not to look at how these systems are performing. I know the regulators are often don't have the budget to go out and routinely survey effluent quality coming out of these systems. So often these things go without sort of being picked up. So this is, again, just a snapshot, screen grab of a review that was done a few years ago here in Australia. So we can see, just looking at the highlighted areas, so this was from a survey of systems in Queensland. And in this case, only 32% of the sites tested complied with BOD solids and total coliform effluent criteria. So that's, again, a relatively high failure rate, 68% failure rate there. One in the middle in Virginia, effluent quality exceeded the standards for BOD solids and coliform 60 to 80% of the time. So again, that's a very high rate of non-compliance. Again, a couple more Australian examples, 58% failed to meet the requirements for BOD and solids. And again, this goes on. So again, there is this evidence base that these systems, even though they may have been certified and tested to have performed, once they're out in the field and maybe they're not being maintained and operated correctly, they can have essentially higher failure rates, which is a problem for public and environmental health in these regions. So there is a need for proper oversight. Some of the reasons these systems aren't performing, as I said before, poor household behaviour and lack of maintenance and oversight of these systems. And also it can be a result of inappropriate adherence to standards and guidelines in terms of the design of these systems. So that's why we need particularly strong standards for the certification, the design and certification of on-site systems, just to ensure that they're performing as they need to be. So moving on to the standards. This isn't by any means complete in terms of coverage. We just sort of did a bit of a whip around of a few different regions, if you like, globally. So in the US, hopefully some of you or many of you will be familiar with this NSF 40 testing standard. So I believe there's a new one actually came out in 2019. So I'm assuming that's the same as the previous version. Maybe we can discuss that later on if there are differences between the two standards. In Europe, they have this 12566-3, which is same sort of thing, certification of on-site systems up to 50 person equivalents. And in Australia, we have a Australian standard 1546.3, which was revised in 2017. That covers, again, systems in that sort of 1,000 to 5,000 litres per day range. So if you dig into these standards, they're all sort of similar, or they're largely based on a common theme, of which emerged from Europe, I believe. So they have testing performance program for between 26 and 38 weeks. They include steady state periods and also stress testing conditions. So these stresses are there to simulate challenging events or challenging conditions for these systems, such as power failure, overload, people going on holiday, so you have vacation or no flow periods in there. In terms of the Australian standard, so this is just a screenshot of part of the testing schedule. So it goes for 32, I think 32, 36 weeks for this one. So it's not covering the whole lot here, but this is just to give you an idea of what it looks like. So we've got these steady state periods here, and then you go into these stress test events where you have a simulated event. Here's a laundry. So this is a simulated discharge of 3 wash loads of, I think it was 150 litres each or something. And then you test for 3 subsequent days after that, and then you go back to your steady state, and then again followed by another stress test event, and it goes on for the whole test period. In terms of these standards, the general configuration in terms of that part of it operationally is sort of pretty much common among the standards, but there are quite noticeable differences in water quality requirements between these standards, both in terms of the acceptable sewage quality, but also in particular the treated effluent quality. So we'll just be going into that in a bit more detail in the coming slides. So this is just a table summarising again the European, USA and the Australian numbers here around sewage quality specification. So this is your influent water quality. So in Europe, for looking at BAD, for example, acceptable sewage quality is anywhere between 150 and 500 BAD. In the US, it's a bit more towards the low end, so 100 to 300. And that's based on a 30-day average, unlike the Australian and European standards. And in Australia, we can go a little bit higher again, so we can go up to 750 milligrams BAD. But there is this requirement in Australia for the sewage to have an average BAD of at least 300 milligrams per litre, which is a new requirement, which wasn't in the previous version of the standard from 2008. Which was more in line with the US standard. So this requirement is a new one, and it's the same for total suspended solids. So both of these parameters need to be at least 300 milligrams in the sewage. So in terms of comparing it to these other international standards, it's relatively stringent. So for example, in Europe or in the US, you could have a compliant sewage with BAD as much as 2 to 3 times less strong than Australian sewage, and 1.5 to 3 times less for total suspended solids. So from that perspective, the systems here would be getting pushed a bit harder than they would in Europe or America. In terms of the treated effluent quality requirements, again, looking at Europe, and this is Germany in particular, so they're German regulations for systems of up to 50 people. They have a requirement of 40 milligrams BAD coming out, or an upper limit, of 40 milligrams. In the US, for that NSF standard, it's 30 milligrams based on a 30-day average. There's also an option there for carbonaceous BAD of 25, which the other standards don't have. In Australia, we're again a little bit more stringent. So for basic secondary quality, you need to be meeting this 20 milligrams limit 90% of the time. You can have some values, you can have 10% of your values between 20 and 30, but most of them need to be 20 or less. And same for suspended solids. So again, the Australian standard is just that little bit more stringent in terms of effluent quality requirements for these on-site systems. And the Australian standard also has this category for advanced secondary quality. So that's even tighter. Again, you need to be at 10 milligrams for BOD in solids most of the time, with a maximum of 20. So that's really targeting very high quality effluent there, particularly for this advanced secondary quality. So that's giving you a bit of an overview of the standards in a few regions, and then obviously we're focusing on this Australian standard for what we're doing here in Adelaide. So ARIS a few years ago built a wastewater compliance testing facility for on-site systems up in the Adelaide Hills to undertake certification performance testing of these systems according to this new standard. So where is it? It's in a little place called Harndorf, which is in the Adelaide Hills, and it's a relatively small little town, 2,000 people, with quite a bit of tourism as well. So the population numbers probably go up and down a bit with tourism influx. It's in a food and wine region and cool climate zone, which is sort of cold-ish winters. It's cold for us. It gets down to, you can get down to about 0 degrees Celsius, which for us is cold. Maybe not for some of you guys over in the US, but that's the climate region we have. Just some pictures here of what Harndorf looks like. Famous Beerenberg. This is a famous jam factory, if you like. So that's where we are. In terms of the compliance testing site, this is at the Harndorf wastewater treatment plant here. So you can see down here we have the testing facility, which is located in one of the old sludge drying lagoons down the back of the plant. The wastewater treatment plant here is at the other end. So just some numbers around the plant very briefly. Its design flow around about a megalitre a day, 5,500 population equivalent load in terms of organic load. It's got a couple of oxidation ditches that they operate, and they have some pre-screening grit removal, then the oxidation ditches, and then clarification, alum dosing for phosphorus removal because effluent's discharged to a nearby creek just in the background then, and chlorine disinfection as well. So in terms of our facility, we're drawing off raw sewage before it comes into the plant. We store it here in this balance tank, and it goes, got a couple of pumps here, positive displacement or cavity pumps here, hooked up to a macerator. So this is allowed by the standard to have sort of coarse maceration here, which we need because we're taking raw unscreened sewage into our plant. So once we go through the pump, it gets pumped down to our little facility here. This is just a few photos showing the setup. So we have, as I said before, within the bed of some disused sludge lagoons down the back of the plant, we've set up a concrete bunker. So these on-site systems can be put in the bunker and backfilled as they would be normally in the ground. So it's fully in-ground testing. So again, some of the details. Sewage comes down from the head of the plant via a feed line, and then it runs along the wall here, and we have these offtakes, which you can see here from the main feed line for each of our treatment units. The dosing is all automated with PLC controls. So that's, again, a requirement of the standard to have specific dose rates and also flow rates as well. The installation is a recent addition. After last winter, we had one morning nothing dosed, and we didn't know why, but it turned out the pipes had actually frozen. So we thought we better wrap them in some insulation to keep them a bit warmer at night time. So as I mentioned before, there's a lot of automation built into the system to control everything and also log some of the parameters that we need to log for our reports that we need to write at the end in terms of flow rates and power use and temperatures and all that sort of thing. So this is just what it looks like in one of the control boxes for the units. We have a shipping container where we sort of our central station for monitoring and controlling things there. The guy who set this up, very clever guy, Chris Devitt, he set up a SCADA system so we can control this remotely as well, which is very handy. So here we just gives you an overview of what we have. So these are each of the systems that we have in the facility here. We can control the sewage mix, which is quite unique here. So we have two different sewer lines feeding into the plant, and we can blend those at times if we need to sort of increase or decrease the strength to manage that. So we're hitting that 300 average limit that I mentioned before. Again, if you zoom into one of these things on the SCADA screen, this is what you see. Power usage, water temperatures in the influent and the aeration chamber, how much wastewater it's received, and all this sort of stuff. So it's quite a nice SCADA system that's been set up there. In terms of auto sampling, the standard requires that we take 24-hour composite influent and effluent samples. So we do that in these sheds here with refrigerated auto samplers, which were custom built for the project. So that's actually been very nice, and it's worked very well. In terms of some of the systems that we're testing on site, for the aerated advanced systems, we've got different types of systems there. So we have some media, MBBR, moving bed bioreactor type systems with suspended media carriers. We have some with more conventional activated sludge type systems. So this is a sequencing batch reactor here with running just a conventional activated sludge biomass. In terms of disinfection, almost all of them are chlorine based disinfection, so chlorine tablets, with the exception of one system, and that again is quite reliable for these sort of on-site systems. So other types of systems, we have passive soil-based systems here. This is actually a US system here, so some of you might recognize that one. And another different variation, an Australian system here. So this is essentially a single pass sand filter type system. We're dosing to a sand bed, and then it's filtering through the sand bed, and we're collecting the effluent coming out for testing. So we also have some soil plus plant based systems. So this is actually an ARIS technology called the Rhizopod system. Examples here you can see of some systems out in the field. That's what they look like out in the field. So this is basically a septic tank as primary treatment, and then it gets pumped, dosed intermittently to the Rhizopod beds here, as you can see, which are filled with coarse filter sand. And in there you're getting ammonia oxidation and ammonia, some nitrogen removal as well from microbes growing in the sand bed. And you're also getting plant uptake of nitrogen and phosphorus as well as water. So the Rhizopods can be configured in some cases as a zero discharge system, which if there are constraints on the site in terms of proximity to waterways and that sort of thing, that's where these systems become quite handy. So we're testing those up there at the moment as well. More R&D type systems up there. So we have something up there that we're having a bit of a play around with called the anaerobic baffled reactor, which is basically a multi-baffled septic tank, if you like. So if you look at these things in the literature, the idea is basically you put more baffles in than you would a normal septic tank, and you basically improve the hydraulic performance of these systems, which improves solids and BOD removal. So they can be particularly good for high strength organic wastewaters because you have this long or longer hydraulic retention time to allow for organic digestion in there. and where the initial idea was to maybe test these for high strength applications such as recreational vehicle dump point wastewater discharge applications. So that's a bit of a introduction to the facility. What did we see? So this is looking at the sewage quality. This is just taking a bit of data from the previous year's testing round. So we saw sewage quality that met the requirements of this standard in terms of being at least 300 milligrams per litre for BAD and solids. So that was good. At times for BAD, you can see up to sort of 500 milligrams, and usually not below sort of 250 or 200 milligrams for BAD. So that gives you an idea of the strength of the sewage we're talking about. All the other parameters again in line with what was required by the standard, so that was good. In terms of how the systems performed, these results, given that it's a commercial testing facility, I obviously can't disclose anything about which systems performed in what way, but we can talk generally about some of the systems and give some of the performance data in a little while. Overall, a lot of the systems struggled to meet effluent quality targets, in particular for BOD. And we have spent a lot of time working with some of the manufacturers, suppliers of these systems to try and help them improve the system performance, given that a lot of these units were designed and tested previously based on the old Australian standard, which, if you remember from slides before, didn't have that same requirement for that 300 milligram average BAD. So essentially the standard has become a lot more stringent, and the systems struggle to cope with that extra BOD load, if you like. So in particular, a lot of the systems which had low media surface area struggled with this BOD because they didn't have enough active biomass in there to meet that BOD removal requirement. And in terms of looking at the soil-based systems versus the aerobic systems, interestingly, the soil, or perhaps unsurprisingly, the soil-based systems were more consistent. Even if they didn't always meet the effluent quality requirements, they were much more consistent in terms of performance, much more stable. Okay, so this just gives a bit of a snapshot of one of the systems in terms of the effluent quality. So as I mentioned before, this requirement to have 90% of your values less than 20 milligrams BOD coming out is particularly challenging. So if we look at the blue line here, this is showing the BOD of the treated effluent coming out. And you can see each of these circled data points here is a failure, is a technical failure, because it's over that 30 milligram maximum value. So yeah, that's a bit of a problem for some of these systems. Interestingly, in terms of the standard, my feeling is it's probably, or it is very stringent, perhaps a little bit too stringent. So if you look at the, in this case, all these values mean the system failed, but if you look at the average performance of these systems in terms of across the whole period, you're looking at about an average BOD coming out of between 10 and 15 milligrams per litre. So that would suggest it's actually on average performing quite well, even though you have these occasional spikes in BOD. So yeah, maybe we can talk a bit about that after, if anyone's interested, as to whether that's a fair way to assess these systems. Obviously, the US standard works on a rolling average value rather than individual points. So perhaps if this was in the US, maybe it would be a pass rather than a fail. So in terms of solids, that was much less problematic. So systems, most of them, if not all of them, had no issues meeting that solids requirement of below 30 milligrams. And we didn't have any systems, or we did have one system that was targeting nutrient removal, but they changed to abandon that just go to basic secondary without nutrient removal because it was quite challenging to achieve. So they had a lot of issues getting good dosing control for alum dosing. Sometimes it was overdosed and we had aluminium toxicity, which killed off some of their nitrifying biomass. So it was a bit of a double-edged sword for those guys. So they ended up abandoning their alum dosing for that system. What other things have we learned? Valves aren't valves. That's one thing for sure. We've burned through a lot of these valves. So these are our flow modulating ball valves, and yeah, it definitely pays to get good quality gear. I mean, these weren't exactly cheap, but they just seem to be unreliable. So yeah, we could talk about components at length, but we won't go into that. In terms of the on-site systems, sometimes having the latest technology makes sense in some applications. So maybe for cars, that's a clear yes, technology is great. Other times, maybe having the latest technology doesn't make so much sense. Sheep shearing is probably a good example there. In terms of on-site systems, what we've learned, I think, is that simplicity is a good thing as a design principle in on-site systems. If you want to avoid things failing, then keep it simple. Basically, use quality components, keep it simple. In terms of equipment for these systems, so things like blowers and pumps we found to be very reliable. Some of the plumbing is a bit less reliable, so I guess in the field these systems perhaps get let down by installers, maybe more so than the actual components of these systems. In terms of disinfection, we had one system that was using UV disinfection, and I would suggest that isn't a viable option for on-site systems. It just never performed in this particular application. I think the water quality in terms of clarity, transparency was just never enough to get the targeted UV dose for this particular setup as it was. So chlorine seems to work well. Things do corrode, especially around chlorine, so that's another thing to remember as well in terms of having quality components. So more around what we learned, as I've mentioned previously, so the Australian standard specifies BOD testing. In the US, you can have carbonaceous BOD, which is so BOD can include the carbonaceous plus the nitrogen component of oxygen demand, which can be quite, in some cases, quite significant. So as we mentioned before, so in the American context, you can have individual numbers, presumably that can be quite high, so maybe 50 or 60 milligrams, as long as your rolling average value is below that 40 milligrams requirement, then you're fine for a 7-day average or 25 milligrams for a 30-day average value. Whereas in Australia, technically, anything over 30 is an instant failure, unless you can justify why that number was the way it was for some other performance reason. So in terms of CBOD, I'm a believer that CBOD is probably the way to go for these systems rather than total BOD, particularly if they're not targeting nitrogen or nutrient removal, then having that nitrogenous BOD component in there is essentially or unduly affecting the performance of these systems if you're including that in there, given that 1 milligram of ammonia can consume 4 milligrams of oxygen to nitrify it to nitrate. So I think having CBOD in there is a good thing. We don't have it in our standard, but I would definitely be supporting a move to CBOD. And actually, if you look at the APHA standard methods, they do recommend using CBOD for secondary effluents in there as well. So I could talk for hours about how much I hate the BAD test, and how much of a bad test it is for these systems in particular. We won't go into that now, but if anyone's interested afterwards, we can talk about that. Aris has experienced a lot of issues with getting reliable numbers from BAD tests from different laboratories. So in terms of the BAD test, again, you can argue about where it's come from and whether it's a good test or not. If you actually dig into the origins of it, apparently it's come from, or the 5-day requirement and 20-degree conditions has come from the UK, where the flow times for British rivers to the sea are less than, or they're up to 5 days, and the average summer water temperature was 20 degrees. So that's this historical basis from a long, long time ago, and really nobody has since questioned whether a 5-day BAD test is a good idea or not in terms of assessing the performance of wastewater systems. Also, in the case of on-site systems, discharging to soil, not surface waters, does it make sense to have this requirement for BAD removal, such a stringent requirement? Again, we can talk about that after. In Europe, I know they regulate on COD, so chemical oxygen demand, rather than BAD, and the numbers are again quite a bit higher. So, yeah, we can discuss afterwards whether that's fair and makes sense for on-site systems or not. So I mentioned briefly before, we've had a lot of issues with reliable numbers and reproducible numbers coming out. Actually, the test lab we use has since modified how they do their BAD test because of us and because of all the issues we've had with reliability and reproducibility. In terms of the COD, the carbonaceous oxygen demand to BAD ratio, for sewage, we got actually quite good numbers. So if you look at this figure here, you can see the COD to BAD ratio is relatively consistent for our raw sewage, but when you look at the treated effluent, in particular chlorinated secondary effluent, the numbers are really, they vary quite wildly. So there's really this relationship between COD and BAD breaks down in the effluent. And this is, again, if you look at the literature, it's not uncommon to see this. So this is some data here from a paper, the reference down here if you're interested. And quite often, or almost universally, you see higher BAD numbers for chlorinated effluents versus unchlorinated effluents. So why is this? The theory is that you're converting some of that recalcitrant or hard to digest or break down COD into a more readily available BAD, which can be falsely elevating that BAD signal. So again, in terms of these on-site systems, whether that's fair or not is something we can discuss. I guess if the water coming out of the secondary stage is of a particular quality, and then it goes through a disinfection step, and then you have an increase in BAD because you're breaking up some of that COD and turning it into BAD. Maybe that's not a fair indication of the system's performance from a secondary treatment perspective. So we saw really a lot of issues, and we've had a lot of issues getting reliable numbers some of these units. And if we go, if we think back to that slide before where we had all these spikes in BAD, some of those for sure are related to having high chlorine residual levels in there and interferences of chlorine on the BAD test. So again, we could talk about that afterwards if anyone's interested to delve into that a bit more. So as a result of this aspect, we actually went as far as removing the chlorine disinfection part of some of these systems for testing, because we just found that we had much more reliable numbers without having that chlorinated effluent coming out. And then actually the Australian standard allows for us to test the disinfection performance separately. to the rest of the performance. So that's the way we're doing it for some of these systems. Unfortunately, as I said before, Australian standard doesn't allow for reporting of COD. I wish it did. Some of the European regulations are again based on COD, which makes just a lot more sense to me. So we'd be definitely supporting any move to include COD in future versions of the standard. So some take-home messages. I think it's fair to say we've all learnt a lot in this project, Aris and myself as well. I think if you're thinking of setting up one of these systems for testing on-site wastewater systems, we might say have a think about it again, because it has been a very challenging project on a whole number of levels. So it's not an easy, hasn't been an easy project, that's for sure. So recapping standards internationally in terms of the requirements for testing, the systems are really they're quite similar, like we said, built on around a common theme. The Australian standard, we argue, is probably the most stringent, at least of the ones that we've surveyed, in terms of requirements for BOD in particular, where there was a lot of noise in the Australian on-site industry last year around this 300 milligram requirement for BOD. A lot of people saying that it was too high for on-site systems, and that wasn't sort of reflective of a typical household domestic wastewater. So yeah, again, we've had a lot of discussion here about that over the last 12 months or so. At the moment, it's the 300 milligram requirement still stands. Whether that will be the case in future versions of the standard remains to be seen. But that's what we have to work with at the moment. In terms of the BOD test, yes, definitely support a move to at least including some capacity for COD, which isn't in the current version of the standard. So we'll be keeping an eye on that and involved in those discussions in terms of any future changes to the standard. The compliance testing period is less than a year, so it's between 28 and 36 weeks for these things internationally. Again, is that sufficient to give an indication of how these systems perform long term? We could have a discussion around that. If they're well maintained, it's probably okay, but in reality, as we know, a lot of these systems aren't properly maintained, so that really is an issue once these things hit the field. This wasn't an official requirement. We had some cows break into our testing facility at one point, which was quite interesting. Spent about an hour trying to herd them back out. So yeah, that was something we didn't expect to see, but you never know what you're going to see up at Hahndorf. And I think that's all. So yeah, thank you very much. And I guess we can open up any of those things for discussion if anybody wants to talk more about them.
Thank you very much, Michael. There has been a couple of questions come in on the chat there, which I'll get you to address. One that I've got basically from the last couple of slides that you've got there, the whole philosophy behind the Australian standards increasing the BOD level was the amount of water efficiency which has been brought into Australia because of the droughts. So they were chasing a higher strength effluent. I take it you don't have an issue with that, but you think they should be testing COD rather than BOD? So COD at the higher strength to reflect the smaller volume but higher strength effluent, but swap over the test?
Yeah, I mean, at least include COD. Maybe give the option of a COD or a BOD performance target, just because like I said, we've had, I mean, I have a friend that works at a commercial testing lab for one of the water utilities here in South Australia, and he said they've had ongoing issues for a long time, many years, trying to get reliable numbers from the BOD test, and they've seen the same things with chlorinated effluents and unchlorinated effluents, and chlorine just interferes with the BOD test on a number of levels. You can get false numbers coming from sodium thiosulfate that you add to neutralise the chlorine. You can get a sulfate demand in there, not always, but yeah, so that's just the idea for CAD would be to at least include it, if not move completely to CAD rather than BOD as they do in Germany. It's just so much a better test, cheaper, quicker, and more reliable. So.
Yeah. Now, Kevin's got a couple of questions there about how Harndorf was selected for the test site and basically the inflow wastewater quality and how that changes over, the course of a year with infiltration from stormwater events and that type of thing. And Susanna has a question is on slide 39 is, do you have any reason why those spikes were occurring? Was it something to do with the treatment system itself, or was there an environmental or inflow event?
Yeah. So first, the sewage thing. Yeah, we generally see. I don't know if you can see that. Can you see that screen or not?
Yes, we can see it.
Yeah. Okay. Yeah. So this is the sewage profile over not quite 12 months, but most of 12 months, and definitely there is a seasonal trend. So this is sort of summer period here, generally higher BOD than you see in wintertime, where there's definitely some infiltration, like all sewer networks. So they generally see lower strength sewage during wet weather. So yeah, that's the first question. And the next one about this, yeah, these peaks. Basically, a lot of them, or many of them, we identified were just analytical errors, again, to do with the BOD test. So this one here, you can see systems running along, performing very well, and then you get this weird spike in BOD, and then it goes back to performing very well. So in this case, we saw the same trend for several systems on that particular sampling day. So we just said, okay, well, everybody's numbers are unusually high for that day for BOD results. So we can just scrap those numbers, just put it down to a testing anomaly, and then collect another data point at the end of the testing period to replace those. Yeah, so some of these here, we saw the same trends in some systems having higher numbers at the same time. Some of them coincided with stress testing events. So it's up to you to determine whether that's, again, it becomes difficult to separate when you have such little faith in the BOD test and the numbers coming out, it becomes difficult to really have confidence in what's a real number and what's not. This one here, again, it's going from 5 milligrams one day up to 50, and then back down to 5, and then up to it just becomes a bit of a nightmare to try and work out what's real and what's not, when you're constantly questioning these numbers coming out. So
the grey hairs look good on you, but do you think that when the high strength BOD water was there during the summer, that there was more failures compared to the lower strength during the winter, or was the test that inaccurate upon occasion that it didn't matter whether it was high strength BOD water coming through or low strength, that the analytical variation was more the issue?
Yeah, maybe a bit of both. I think during summer we definitely saw more more high effluent numbers. So this is, say, a summer period here. Some of the systems experience issues with a lot of overgrowth and fouling of, or a lot of excess growth on media and things like that, which could have impacted treatment performance in some way. So we had filters sort of fouling up and clogging and things, overflowing in some cases, and so that was more of a temperature issue, I think, rather than the effluent strength issue. But for sure, maybe a bit of both.
Yep. Ted and Trenton have asked questions as well. Ted's chasing you. Have you compared the any data for the domestic BOD in Australia to get a bit of a feel on what the background data is showing with what's being received at Hahndorf? And Trenton's asked about the maintenance, because all of these systems require maintenance. Are the regular maintenance people coming through and maintaining their on-site wastewater systems? And I'll throw in another one as well. This is one of the first times these systems have been tested under the new Australian standard. How do you feel the Australian Standard Committee is as far as getting feedback on what the new accreditation process is concerned? Do you think any of your queries of putting it into practice or feedback is being appreciated and listened to?
Okay, so the maintenance thing first. Yeah, so the standard allows for the manufacturers of these systems to come in and do the routine, servicing and maintenance as they would normally, as per the whatever their maintenance schedule is for these systems. So it's usually quarterly. So yes, people are allowed to come on site and do the regular maintenance, as long as it's not coinciding with a stress testing week. They can do it during steady state operations. So yes, that's that. In terms of BOD and how that relates to Hahndorf, yeah, it's sort of on par. Possibly, I'm just thinking one of the more domestic plants here in South Australia, which is down at Glenelg. I think their BOD in the sewage runs at about average of, I think, about 220 to 250 milligrams, and that's for, I mean, it's not entirely domestic. It's still in the that's part of Adelaide metropolitan area, which includes other things as well, but there's limited industrial load, if not no industry going in, and yeah, so that's primarily domestic in that range, so 250 to 220. But for the purposes of the standard, if we were to have built this down at Glenelg, it wouldn't pass because we need, or it wouldn't be accepted because we need that minimum 300 requirement according to the standard. So again, we could have a discussion about whether that's a fair reflection of what domestic sewage from a household actually is. And as I said during the presentation, there's been a lot of noise in the industry about that being too high. Maybe it was too low before. So the previous version of the standard again had no average value requirement. It just had this range, so it had to be between 150
to clarification in with his question that is there any more specific knowledge on on-site BOD wastewater? And yeah, I would think it would be highly variable.
Like households. Yeah, no. I've spent a bit of time digging around trying to get numbers from actual household, individual household wastewater quality, and if it's out there, I haven't found it. There's data obviously on things like Hahndorf, small wastewater plants connected to little townships and things like that, but actually I haven't seen anything that gives good data on what's actually coming out of an individual household. So yeah, if anybody knows of that data, I'd love to see it. That'd be really, really good to have. My feeling is that it's the 300 is probably a little bit high for what would be coming out of a household. So yeah, that's my feeling about that. And Ben, your question about standards and how this is
Standards
feeding back
committee,
into.
are they receptive to your feedback?
Oh yeah. So we had, or as you know, Ben, we had an industry forum late last year where a lot of people from the on-site industry in Australia got together with the standards committee and a lot of the state regulators that oversee on-site systems. And yeah, we all had the opportunity to make submissions ahead of that discussion forum. Nothing came out of it in terms of any changes that were going to be made to the standard, but there was a lot of discussion around this sewage strength requirements and whether it's fair. There's been people again making a case that it should be lower than 300, maybe closer to 250. So we'll see what happens in terms of future revisions of the standard, whether it stays at 300 or if it drops back a bit, or yeah, I'm not sure what will happen there or over what time frame that will happen. But yes, they have been
Getting a heap of questions
to,
come through.
Yeah, Ben, what I'm going to suggest is that we keep the questions coming in, and then I'm going to close the actual recording portion here. I just want to draw attention to the next in our series of what we're kind of talking about as the WasteWater TED Talks. Although we did have TED, so we've had an original TED Talk at one point here. June 16th, there is a presentation from the island of Åland in Sweden, where they have a very interesting combination of a desalination plant and a reuse of industrial wastewater into potable drinking, because that part of the world went through 2 years of excessive drought. And you can see there, that's the satellite image of what should be green and it's brown. And that's the island of Åland, which is on the Baltic Sea side of Sweden. Also coming up, let me just put this one up here, is, there we go. Later in June, the following week, is Bomb and Shake, who's going to talk about on the same sort of subject, which is reuse of the resource, using recycled water for agricultural purposes. So what I'd like to do, ladies and gentlemen, I'm going to close the recording now, but if you have a microphone, if you see the little hand symbol there in the top of your screen, if you click that, we can give everyone a microphone. And so with that, Ben, thank you so much for being the host, and thank you, Michael, for this really interesting view of totally different continent, but a lot of the same problems. So thank you so much.